Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, we revolutionized the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges. With our global network of sales and service centers, we aim to respond quickly to your needs and to deliver the highest level of customer satisfaction.
Here with Randy from Alltemated. Hey, I got it right. That's good. Okay, it's a really neat and interesting product that overcomes a lot of the negativity that people have about underfills and reworkability and strength and ease of putting down. So I'm just going to go to you, sir, and say, explain the technology.
Okay, well, you know, as you said, a lot of the issues with underfills are you have to buy an additional dispensing equipment and then a secondary oven, right? So underfills are applied after the assembly is completed. So after solder paste, pick and place, and reflow, now you have to dispense the underfill and then go through another cure cycle, another oven. So you're adding additional line space, a lot of CapEx, and then just all the other things that go along. The underfills have to be stored usually at minus 40 degrees C. They have a shelf life, a very short shelf life, and then of course you have a floor life. So there's all these challenges, right? And so the theory behind the place and bond is it's a pick and placeable element, right? You're adding the adhesive to your feeder. The parts come in tape and reel. So there is no additional equipment, no CapEx. You buy the parts in tape and reel, put them on the feeder. So then as you screen print your paste, you bring it into placement. You're placing all of your components, chip caps, you know, resistors. You put the place and bond elements down, and then you add the component that you're bonding on its solder joints. Then the process is next is it goes through reflow and you're done. So the bonding occurs when it melts in reflow. Your solder joints are forming, the place and bond material melts, and then when you come out of reflow, you've got your solder joints. The material cools, and below its cooling point now it's an adhesive, it's creating a bond. So it's very, very simple, and it eliminates a significant amount of worries with implementing underfill.
Yeah, and I suppose you have it die cut for all the various sizes that you need. How about thicknesses as well?
Yeah, we have many different thicknesses, and then we can laser cut or die cut or punch depending on the size of the part. So we have a series of what we call standard parts, and typically what we do is we work with the customer to figure out what their A1 standoff height is, which would be between where the balls touch the solder pad and then the height to the bottom of the package, the device, right? So that's the gap. We look at that A1 standoff on the data sheet from the component manufacturer's data sheet, and then we size the thickness appropriately to that actual standoff height. That way we're able to guarantee that we get a good fillet and a good bond between the two substrates.
Yeah, and the material doesn't affect any of the bonds even around the outside of the components?
Correct. The material basically is a no flow. So it's an edge corner bond type application. It will, it's maybe more like a low flow. It will leach around and encapsulate maybe the first row or two, but it has no effect on the solder joint formation. Not only do you get 100% solder joint, but with or without our material, you get the same finish height. So if you're what you typically call ball drop, so it has no effect whatsoever. We've done several studies with major manufacturers, and in fact, NXP a while back, a person did a white paper on the technology, and we did a X-ray right off of the reflow line, and basically demonstrated 100% solder joint formation, and no change in the ball drop.
And with drop testing and this kind of stuff, how does it compare to, let's call it the traditional underfill?
Yeah, so because it's what we'll call an edge bond corner bond, it has some aspects in that area where it's, in some cases, we outperform the competition. In fact, we've done some mechanical modeling in comparison to some standard underfills. They're a little bit more rigid, and this particular material is an elastomeric, so it has a much, and the other issue, it softens a little bit at higher temperatures, so it has very good thermal cycle performance, and as well the shock drop. We've done studies where it's anywhere from 8x to 15x improvement, not necessarily over the underfill version, but unsupported, right? Yep. So if you have an unsupported device, we're typically getting 8 to 15x improvement, and a lot of those are done at 3,000 Gs, so which is above the 1,500 Gs. So it's a substantial improvement in mechanical shock drop.
Yeah, and I guess the big thing for a lot of manufacturers, especially in like aerospace and military and this kind of stuff, is that this is reworkable, whereas your standard underfill is a complete nightmare.
Yes, yeah, it's definitely found a space in the market, many applications because of the reworkability, the ease of implementation. Most customers come to us early on when we've first started investigating underfill, and they're scared away, very, very quickly about the implementation, the CapEx, the secondary processes, the floor space that the secondary processes, and when they find that this product goes on a standard SMT feeder, it's part of the pick and place process, and it's 100% reworkable, they get very excited. And we have many success stories from, most of the products are PDAs, laptops, cell phones, a lot of SSD type drives, getting into the automotive space with, had a motorcycle, a person with actually an Italian manufacturer with a gauge, a dash gauge, that he got that implemented. So there's a broad spectrum of usage out there, and it's growing every day.
Yeah, so you've got high volume and harsh environment stuff, huh?
Yeah, so the thermal cycling, we've passed on some platforms from -40 to 125 C, which is a very stringent thermal cycle. The material itself, though, it's probably not necessarily for space. We've had some outgassing testing done, and I have one customer that they found it acceptable for their application. Another customer was thinking that, for their application that it wasn't a good fit. So, but we have a lot of test data, everything from thermal cycling, the shock drop. We've got SIR testing. So we have quite a bit of third-party data that we have as well.
Yeah. So you've got a lot, as you say, you've got a lot of data to back the product up, and the product has a lot of advantages over the other products that are out there trying to do the same thing.
Absolutely. Yep.
Okay, and I think you've brought something to show us as well. So.
Yeah. I have a feeder, so you can see that the parts, the elements are in carrier tape, presented to the PIC nozzle, and this is a standard Panasonic feeder, so no special tools, no special equipment. We do some really tiny parts in some cell phones and things. In fact, we have a part that was actually used as a dam for a conformal coat.
Yep.
The conformal coating was getting on the contacts and causing a problem, so we have a really small part that's not actually used for BGA reliability and or mechanical use, but actually a conformal coat dam. That particular part was so tiny they did have to get a custom nozzle.
Yep.
So, but and then as well, our customers, the yield rate is always right. So they want a 99.9% pick and place yield. So,
yep.
But again, it's just a standard adhesive. It's a dry film, so it doesn't stick to the carrier tape. And then typically we apply a micro dot of a PSA adhesive. So once you pull the cover tape off and you pick the element out and you're placing it on the circuit board, the PSA dot is underneath the nozzle, and it makes it self-tack.
Yeah, just holds everything where it needs to be.
Yes, absolutely. So it's pretty simple, no extra equipment needed, and it's a wonderful way to improve the shock drop and mechanical.
Yeah, it sounds like a very simple and straightforward way for anybody who needs to improve the reliability of pretty much anything that they've got on the board.
Yeah.
Even if it's a plated through device that vibrates a lot in real use, and you want something that's going to hold it down onto the board, rather than having to do something after the production line with a gun and some sealer or whatever, then you can just put something underneath it and you stick it through the soldering process and you're done.
Correct. I mean, the latest applications, our newest products that we've been developing are for electrolytic capacitors. Customers are having double-sided reflow problems, or they're just knocking knocking the capacitors off. So we've got several customers now. They're putting place and bond between the legs on the electrolytic. We've got connectors, so we've got customers with edge connectors, and they're putting place and bond underneath the edge connector. So it's finding many more uses. One of our highest applications would be soldering a flex circuit directly to a rigid board, right? They're eliminating the need for a rigid flex because a rigid flex is very expensive, and they're direct soldering a flex circuit to the rigid board. They put our strip on the edge of the board where the flex tail comes off, and so once they go through reflow, they've got their solder joints between the two substrates, and then they've got our adhesive strip creates the strain relief.
Yeah, I was going to say, you've got extra strength and strain relief.
Yeah, and like you said, you don't have to then put a bead of RTV down on the edge of the board to glue the flex tail.
And you've got something that's much more reliable and much more repeatable anyway.
Yes, for sure.
Well, okay, that's been a very interesting chat, and I want to thank you for coming in and sharing with us. And this is Keith Bryant for Global SMT and Packaging, signing off from Apex 2022.